Okay, so we're going to be looking at the properties of equality and then jumping into algebraic proofs. So what I thought we could do is talk about the actual properties we're going to use, which we did mention this in previous videos, and then also look at a couple of examples, okay? So the main ones we want to focus on are addition, subtraction, multiplication, and division. However, we are also going to use the distributive property. Rarely will you see these guys in the proofs that we're going to be working on. However, it doesn't hurt to know them. So mainly we're going to focus on these guys, okay? Now, when we're talking about addition, property of equality, subtraction, property of equality, multiplication, division, and so on, remember from the previous videos we said we can add the same thing to both sides, we can subtract the same thing from both sides, multiply the same thing to both sides, and divide the same thing from both sides. Those are the properties that we're referring to. It's just we're being a little bit more formal now. So if we look at the addition property of equality, it says if A equals B, then A plus C equals B plus C. Okay, so all that means is I can add the same thing to both sides and I maintain equality. For instance, if I give you x equals 1, I can add the same number. It doesn't matter what any number we're talking about. Let's pick the arbitrary number 2. If I add 2 to both sides, I still maintain equality. Okay, as long as I add the same thing to both sides, I maintain equality. Okay, just like what we were doing when we were solving one-step equations, two-step equations, and multi-step equations. Okay, the subtraction property of equality, you guessed it, says I can subtract the same thing from both sides. Okay, so if A equals B, then A minus C equals B minus C. Okay, so I can subtract the same thing for both sides. Well, let's go back to our example over here. Okay, so this was for this guy. Now let's look at this guy here. Using the same idea, if I have x equals 1, then I can subtract the same thing from both sides. Let's use our arbitrary number 2 again. That means I can have x minus 2 is equal to 1 minus 2. I can subtract the same number as long as I do it to both sides. Okay. The multiplication property of equality. If A equals B, then A times C equals B times C. I can multiply the same number to both sides, okay? Using that same example that we have over here, let's start off with our x equals 1. So I can multiply the same number to both sides. In this case, let's continue to use our arbitrary number 2. I can multiply 2 to both sides. 2 times x is equal to 1 times 2, okay? As long as you multiply it to both sides, we have equality, okay? Then the division property of equality says if A equals B, then A divided by C equals B divided by C. And even though they didn't write it in there, just understand we can't divide by 0, so C can't be 0, okay? So C cannot be 0. Okay, so I can divide the same thing to both sides, okay? We can still use the same example, starting off with x equals 1. As long as I divide by the same thing, in this case, let's divide by 2, it maintains equality. As long as I divide by the same thing, I maintain equality. Okay, so those are the main ones we want to focus on, okay? Now, the other one that you may come across that might be common here is the distributive property, which we've already kind of gone over this before when we did the combining like terms and the distributive property. We know if I have some number in front of the parentheses, we multiply that to each one on the inside. For instance, if I had 2 times x plus 1, okay, we could multiply this and we'd have 2 times x is 2x. And then 2 times 1 is 2, okay? So we might apply the distributive property at some point. And then also, if we have to add or combine like terms, that's another thing that we might come across, even though it's not written on here. Also understand combine like terms is something that we might use, okay? So if you want to make a side note here, that's another step that we might use when we're going through these algebraic proofs is combine like terms, okay? Now, the last of these guys, we're not necessarily going to use these in the proofs, but it doesn't hurt to know it because once in a while in these proofs, you might use, for instance, the symmetric property to switch the x and the number, okay? So the substitution property of equality, all that says is if I have 2 equal things, I can substitute one for the other. Okay, for instance, if I know A equals 1 and A equals B, okay? If I know that that's true, then can't I substitute or replace A and B so that B is equal to 1? Okay, and actually that's a special case of the substitution property, which we would call the transitive property. But in this case, the theory is still applied here, or the content is still applied here. B can be replaced, or excuse me, A can be replaced with B, so B is equal to 1. Okay, then we have the reflexive property, which says A is equal to A, something is equal to itself, 1 is equal to 1, 2 is equal to 2, and so on. Symmetric property, that's the one that I think you might run into, okay? All that says is if x equals 2, then 2 is equal to x. Okay, so it doesn't matter the order in which we write it to, in the order in which we write it, it's still the same thing. X equals 2 and 2 equals x. And then actually that example I used for the substitution property, that would be a better example of the transitive property, because the transitive property says if A equals B and B equals C, then A equals C, okay? So it's like taking out the middleman. So in a way, this was a better example for the transitive property, okay? So if B is equal to A and A equals 1, then B equals 1, okay? So that'd be the example of the transitive property, okay? Now, again, for our algebraic proofs, we want to focus on this, okay? So this is an algebraic proof. We're still going to be solving equations, whether it's one-step, two-step, or multi-step equations. They're going to give us a statement, and we want to prove what x or n or whatever the variable is equal to, okay? But the thing about proofs is we have to provide a reason behind each step that we take, okay? So we're going to see statements, okay? The statements, in other words, each step in the proof, and then the reasons. That's the reasons that we're applying those properties of equality that allows us to take the steps, okay? Now, this is important. Every time we start a proof, you always start with the given information. So notice this and this are exactly the same. We always start with the given information. So our first reason, the reason we can make this statement is because that information was given to us. This is always how we're going to start the proof, with the given information for our statement, and then our first reason will always be given. Okay? Now, the next thing we want to do is follow the steps and see if we can understand how they get to the next step. So look for the difference between the two steps. What do you notice that is different between step 1 and step 2? Well, notice if I subtract 3x to both sides, isn't 8 minus 3 5x? Well, yeah. So what they're doing is they're moving that 3x to the other side. But how are they doing it? They're subtracting 3x from both sides. Which property says I can subtract things from both sides? The subtraction property of equality. So the reason I can move 3x to this side and make it into a 5x is the subtraction property of equality. Okay, so that's the reason that we can make this statement. And I don't care if you want to shorthand it like this, just as long as we're on the same page, okay? So we subtracted 3x from both sides, which gave us 5x, and that would be the subtraction property of equality, okay? Then, look for the difference between steps 2 and 3, okay? What changes between 2 and 3? Well, notice, if I add 18 to both sides, 12 plus 18 is 30, right? So if I add 18 to both sides, that's going to get me to 30. Well, which property says I can add the same number to both sides? The addition property of equality. So the reason we can add 18 to both sides is the addition property of equality. Okay? So then again, we're looking for the changes between these two steps now, okay? How can I go from the first statement here, which is statement number 3, to statement number 4? Well, notice if I divide by 5, just like we normally would when we're solving equations, okay? 30 divided by 5 is 6, okay? So in this case, we divided by 5 to get the x by itself, and that gives me 6, okay? Well, which property says I can divide the same thing from both sides? The division property of equality. The division property of equality. Okay, so last thing here, notice this is the one that I was telling you that might show up, but most of the time it's not going to be that big of a deal for me, but it doesn't hurt to note it, to recognize it. Notice they go from 6 equals x to x equals 6. Aren't those two statements the exact same thing? Yes, it's just it's written in a different order. Well, that guy was the symmetric property of equality, okay? Whoops, that's not what I wanted. The symmetric property of equality, which said if x equals 2, then 2 equals x, okay? So they're the same thing. So we can say that's the symmetric property of equality. Okay, so that would be an example of a proof. Now, sometimes they don't give you the statements and you actually have to solve and then provide reasons why you're solving it the way you are. So I want to look at one of those, specifically one with the parentheses, okay, and see if we can solve this guy. Okay, so now in this one, again, we always start with the given information. So I'm given 3 times 5x plus 1 equals 13x plus 5, and that is given to us, okay? What we want to prove is that x is equal to 1, okay? So our answer better come out to be x equals 1 or we did it wrong, okay? Now, going based off of what we talked about with multi-step equations, how would you solve this? What would be your first step here? Well, we apply the distributive property, right? So I'm going to multiply 3 times 5 to get 15x. Okay, so 3 times 5 is 15x. And then 3 times 1 over here is 3. Okay, so we get 15x plus 3 is equal to 13x plus 5. So we're going to take this one step at a time. Make sure you're taking this one step at a time. So all we've done so far is apply the distributive property. Well, that in fact is our first reason after the given here. What allows us to go from step number 1 to step number 2? What did we do? We applied the distributive property. The distributive property. And don't forget, step number 2 when we're solving multi-step equations was what? Combine like terms, right? Can I combine like terms on either one of these? No. But keep in mind, every once in a while, that might be the reason over here. That might be something that you have to write over here is combine like terms. It's just in this case, we have nothing to combine, so we don't have to worry about this, but it could come up. So I just want to make mention of that, okay? So we don't have to worry about combine like terms. Next step was to get x by itself by picking a variable side and pick a number side. Well, let's keep x on the left and move all numbers on the right. So if that's the case, I need to move this 13 over here, right? Well, how do I move a positive 13x? I subtract it, right? So I'm going to subtract 13x from both sides, and I get 2x plus 3 equals, inverses cancel out, 5. Now, how did we move from step 2 to step 3? We subtracted 13x, right? Well, if I subtract it from both sides, that's the subtraction property of equality. The subtraction property of equality. Okay? Again, what do we do next? It's a 2-step equation. Well, we do the addition subtraction part first. I got to move the 3 over to the number side. So I'm going to subtract 3 from both sides. And I get 2x. Inverses cancel out is equal to 2. Well, what did we do to both sides? We subtracted 3, right? So what is my reason that I can do that? The subtraction property of equality. It's okay if you apply it twice, you just got to write the reason. So we applied the subtraction property of equality again. Okay? Last step here to get x by itself. Remember, we have multiplication here, so what's the opposite? Divide by 2. And we get 5 on statement 5 here. X, because my inverses cancel out, is equal to 1, which is what we wanted, right? So we get x equals 1. Now, why were we able to do that? What did we do to both sides? We divided, right? So the last reason here would be the division property of equality. Okay? So this is just a couple of examples, and we'll go through some more tomorrow.